Alright guys, let's look at this next question from Cat24, the first lot. You can pause the video and try it once and then resume for the solution. So Cat24 surprisingly has seen the return of remainder based questions, and every slot had one question from remainders theorem and they were all super easy. So let's see this one. There are multiple ways of answering this question. First way could be you want the remainder of 10 raised to 100 divided by 7. So we start by dividing 10 with 7. If we divide 10 with 7, 7 ones are 7, the remainder would be 3. So now we can simply change this question to what is the remainder of 3 raised to 100 divided by 7. Remember, we have studied this concept in our course, guys, and that is whatever we are doing with the numbers, the same thing will happen with the remainders. So if 10 gets divided by 7 giving you the remainder 3, 10 raised to 100 will be replaced by the remainder 3 raised to 100. Okay. Further, we have to find out a power of 3 which is. So we start with 3 raised to 1. Is 3 raised to 1 more or 1 less than a corresponding multiple of 7? Absolutely not. So we check 3 square. 3 square is 9. Is 9 1 more or 1 less than a corresponding multiple of 7? The answer is no. What about the next power of 3? 3 raised to 3. 3 power 3 is 27. Is 27 1 less or 1 more than a multiple of 7? The answer is yes, it is. So we select 3 raised to 3 and we try to get 3 raised to 3 in this particular expression. We start by writing this as 3 raised to 99 plus 1. We are writing 100 as 99 plus 1, and this part is technically 3 raised to 99 into 3 raised to 1 using our first law of indices. Now 3 power 99 can be further broken down to 3 power 3 into 33, and 3 power 1 will be again as it is. Now 3 power 3 into 33 is nothing but 3 power 3 the whole raised to 33. Once again our law of indices, a raised to m into n is a raised to m the whole raised to n. So this part becomes 3 raised to 3 the whole power 33 into 3 raised to 1 is equal to 3 power 3 is 27 and 27 raised to 33 is multiplied by 3 raised to 1 further. And now if you observe carefully, this part will be divided by 7 and this part will be divided by 7. We'll find out the remainders and multiply them. So what is the remainder when 27 raised to 33 is divided by 7? We'll first find out the remainder when 27 is divided by 7. If you divide 27 by 7, there are two ways out. You can write 7 3s are 21, or here you can select 7 4s are 28. You get the negative remainder minus 1. So this entire part will now become minus 1 raised to 33, and 3 on dividing by 7 will give the remainder 3 only. So everything now boils down to minus 1 raised to 33 into 3. Well, minus 1 is raised to an odd power, so this part will simply be minus 1 only, and it's multiplied by 3, so it's nothing but minus 3. So my remainder is minus 3. What I do is I add this to my divisor 7. Minus 3 plus 7, I get my final remainder as 4, and that's the answer to my question. The answer is option D, the remainder being 4. So this is how we can conventionally solve this question. There are many more ways out. You can start by taking 10 raised to 100 as 10 raised to 2 the whole raised to 50 also. This becomes 100 raised to 50 divided by 7. If I divide 100 with 7, my remainder will be 2. So the question changes to 2 raised to 50 divided by 7. And now this can be written as 2 raised to 48 into 2 raised to 2 divided by 7. 2 raised to 48 is 2 cube the whole raised to 16, and 2 square is simply 4. 2 cube being 8, it becomes 8 raised to 16 into 4. Now 8 when divided by 7, the remainder will be 1. So this part, the first part is 1 power 16 into 4 as it is. 1 power 16 is 1 only, and 1 into 4 again gives the remainder as 4, the D option. And like this we could keep on taking different powers of 10 to further simplify this and get the same remainder 4. Now let's look at a very quick shortcut for all these questions. And for that we will need something called as the Euler's theorem. We have discussed this Euler's theorem in the course. You can check out the link in the description for the course. In that we have completely discussed the Euler's theorem. Now, we start by finding out the Euler's number of 7. 7 being a prime number, the Euler's number is very simple to find. 7 minus 1 is equal to 6. Now, the Euler's theorem tells us that since 10 and the divisor 7 are co-prime, have nothing in common, whenever 10 is raised to a multiple of 6, the remainder with 7 will always be equal to 1. So 10 raised to 6 on dividing by 7 gives the remainder 1. 10 raised to 12 on dividing by 7 gives the remainder 1. 10 raised to 18 on dividing by 7 gives the remainder 1. So we have to find out the multiple of 6 close to 100 in this case. It will be 10 raised to 96. So 10 raised to 96 on divided by 7 will give you a remainder of 1. And now, having this knowledge, we can further split 10 raised to 100 as 10 raised to 96 plus 4, which is 10 raised to 96 into 10 raised to 4. My question changes to, what is the remainder of this entire thing when divided by 7? Well, for this part, we already know the remainder is 1. So I simply need to find out the remainder of 10 raised to 4 on dividing with 7. So my final question boils down to 10 raised to 4's remainder when divided by 7. 10 divided by 7, the remainder is 3. So the remainder will be same as 3 raised to 4, which is 81. But 81 is way greater than 7. So once again, we divide 81 by 7. 7 11 are 77. My remainder will be 4. And once again, we get the D option. All this explanation was just for you to visualize things properly. If you're already aware of the Euler's theorem, you can directly look at this particular step and start solving and get the answer quickly. If you're not very much sure of the concept, once again, you can check out the link in the description for my course. I've explained the Euler's theorem and all the other concepts in great depth.